Greetings, everyone. This is Mark Anderson from Kellogg Community College, and we're going to look at this pattern called the difference of squares pattern. Now I'm going to be very literal about this. Difference, meaning subtraction. So this has to be a subtraction problem. Difference of squares, though. Okay, so what do I mean by that? What I mean is that each of the terms in this binomial is in fact square. So in terms of integers, let's look at just some positive square integers like 1, 4, 9, 16, 25, 36, 49, let's see, 64. Okay, so this is a list of square numbers created by squaring a number. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on. You will commonly see all of these up to 12 times 12, which is 144. So these are in fact squares. And in terms of powers, x squared is a square, and so is x to the fourth. That's x squared times x squared. And x to the eighth, which is x to the fourth raised to the second power. So this is just an example of some things that you might see along the way here. And you know, every once in a while you'll get an x to the sixth, which is x cubed squared, but I'd say these are the most common that you will see on most tests. But again, you can see any even power, and that's technically a difference. That would still work in the difference of squares pattern. So what does this all mean then? Like, what happens when I get to a binomial of x squared minus 16? Well, what that means is that I can easily factor it as to x plus 4, x minus 4, and whoa, really? That was quick, and that's it. Yeah, it is, because you see, the reason why this has two terms is because this actually has no middle term. This is x squared plus 0x minus 16. I know that looks like ox, but it's 0x, which means that if I go x times negative 4, and then x times 4, my O and my I cable of my FOIL, my O and my I simplify to make 0. So in my problem up above in number 33, there is no O and I, so this has to be a plus and a minus. They can't be both minus, they can't be both plus, because that would not simplify out this middle term here. So this x squared minus 16 is my final answer if I FOILed that out. And the pattern works very nicely as long as you have a square and another square. So this would be the square root of x squared is x, the square root of 4 is 2. All right, this is x plus 2, x minus 2. That's kind of nice. And it's also rather quick, too. I mean, is this a square? Yeah, it is. 9x squared can be square rooted to 3x and 3x. And also this negative 1 can be square rooted to 1. You know, notice that's a square number right up there. So, yeah, plus minus. But what if you wanted to write it minus plus? Yeah, that's fine, too. So, check out number 36. Here we go. 4x plus 5 and 4x minus 5. Yeah, this is a very quick pattern once you recognize that this is a square number. 16 is a square number, and so is 25, and it's the difference of squares, so that works. And these last two problems, to finish the video, are going to take things just a little bit further, because this x to the fourth, whoa, see, there it is a square number, which is x squared and x squared. All right, now I can get very technical here and tell you that the square root of x to the fourth is the same thing as x to the fourth raised to the 1/2 power, and 4 times 1/2 is 2. But I think you're going to want to wait till I get to the radical chapter. That's not means like radical, but like actually the term dealing with these powers here, and especially powers as fractions, the radical chapter. Okay, so that was very quick, and I'm sorry to kind of like speed through that, but really that's working a couple chapters ahead. So again, back to this, x to the fourth is really x squared times x squared, so we put those here. 1 times 1 is 1. Okay, so we'll put here a 1. Hold on, put a 1 here and a 1 here. So plus and minus. Okay, so you think we're done, right? But look at the x squared minus 1. That's x plus 1, x minus 1. See, that's a difference of squares too. Check that out, x squared plus 1. Man, see, that's right there. That is done, and you can't do anything with it after that. And this x squared plus 1 is like, oh man, but I can split that up, and you can't. Because this is a difference of squares pattern, not an addition of squares pattern. So you see this answer, which has 3 binomials in it? This is our final answer. Because we could have legally split that up because it was the difference of squares. And we can't split that up. Can't split that up because it is not the difference of squares. That's prime. Okay, look at number 28, or 38, excuse me. Don't you want to just put down x plus 4x minus 4? I know you do, but you can't. This is prime. Unless you and I have had a discussion on imaginary numbers, which we haven't yet, you can't do anything with this, because x squared plus 16 is not a difference of squares pattern. Just like this binomial and the problem before it, you can't do anything with it. You can't do anything with it here. I was trying to trick you, and yeah, if that was x squared minus 16, ba-bam, you could have done x plus 4x minus 4. But since it wasn't x squared minus 16, that one's prime. And it's an easy trick or trap. So yeah, just get to learn some of this stuff here, and thank you very much for watching. And great, we'll do more factoring in later videos.